Computer hardware. The physical elements of a computer, its hardware, are generally divided into the central processing unit (CPU), main memory, or random access memory (RAM), and peripheral. The last class encompasses all sorts of input and output devices: keyboard, display monitor, printer, disk drives, network connections, scanners, and more. The CPU and RAM are integrated circuits, small silicon wafers or chips that contain thousands or millions of transistors that function as electrical switches. In 1965, Gordon Moore, one of the founders of Intel, stated what has become known as Moore's Law: the number of transistors on a chip doubles about every 18 months. Moore suggested that financial constraints would soon cause his law to break down, but it has been remarkably accurate for far longer than he first envisioned. It now appears that technical consistency may finally invalidate Moore's law, since sometime between 2010 and 2020 transistors would have to consist of only a few atoms each, at which point the laws of quantum physics imply that they would cease to function reliably. Central processing unit, the CPU, provides the circuits that implement the computer's instruction set, its machine language. It is composed of an arithmetic logic unit and control circuits. The ALU carries out basic arithmetic and logic operations, and the control section determines the sequence of operations, including branch instructions that transfer control from one part of a program to another. Although the main memory was once considered part of the CPU, today it is regarded as separate. The boundaries shift, however, and CPU chips now also contain some high-speed cache memory where data and instructions are temporarily stored the fast access. The ALU has circuits that add, subtract, multiply, and divide to arithmetic value, as well as circuits for logic operations such as AND and OR, where 1 is interpreted as true and 0 as false, so that, for instance, 1 and 0 is equal to 0. See Boolean algebra. The ALU has several to more than 100 registers that temporarily hold results of its computations for further arithmetic operations or for transfer to main memory. The circuits in the CPU control section provide branch instructions which make elementary decisions about what instructions to execute next. For example, a branch instruction might be if the result of the last ALU operation is negative, jump to location A in the program, otherwise continue with the following instruction. Such instructions allow if then else decisions in a program and execution of a sequence of instructions such as a while loop that repeatedly does some set of instructions while some condition is met. A related instruction is the subroutine call, which transfers execution to be a subprogram, and then after the subprogram finishes returns to the main program where it left off.